All right, guys, a couple more. Problem 72. A rock falls from a tower. It's 160 feet high. It's falling. Its height is given by the formula. So we have a formula, and we're going to type in that formula into either Desmos or our graphing calculator. Minus 16. Again, on the calculator, I'm using X. You can use T on Desmos. How many seconds will it take for the rock to hit the ground? All right. So the first thing we might want to notice is that the height at time 0, since the height is given as a function of time, the height at time 0, if you replace t with 0, you get 160. So that means that at 100, is it feet? Yeah. So at 160 feet high, that confirms what it tells us in the first sentence, by the way. At 160 feet high, this is the x, and then this is the height in terms of x. And this, I know it's height in terms of t, but on my calculator I have an x. So the height is 160 at the beginning, and a rock falls from the tower. As it is falling, its height is given by how many? So this is number of seconds. So the x-axis or the t-axis is in seconds. So as time goes by, as time goes on, we should get a graph like that because we have a parabola, and the parabola will have an x-intercept, a y-intercept. So the y-intercept is 160, okay, because h of 0 is 160. And if we replace x with, well, let's do this first. Let's, not really sure how many seconds it'll be in the air, but we can kind of estimate. And then we know that's not going to be any higher than 160, so let's just put 170. And then let's take a look. All right, so that was pretty fast to see that, but that's the graph of the parabola. And here's something that's kind of cool. If you change that guy, you can change it from that to, this is kind of neat. So take a look at the screen here, graph. And if we show scale, let's see here. Oh, XRes, let's do 0.5. Watch this. I guess it's not doing what I thought it was going to do. So don't mind me. All right, so what are we being asked to find? So how many seconds will it take for the rock to hit the ground? Well, if we trace this and we go, oh gosh, okay, there we go. So if we trace it, we can see right there when time is 0, when x is 0, again, that's the time, the rock is 160 feet high. Well, at about the 1 second mark, the rock has fallen. So the height is given. So the height, I shouldn't say the rock has fallen. The height would be 143 feet. So the rock has fallen about 17 feet. And then it's fallen about like a little over 60 feet, like 67 feet. So at about the 2 second mark, it has fallen about 67 feet. And it currently is 93 feet high. Well, when does it hit the ground? Well, let's do this. Let's show negative 30 so we can see where the ground is. So you can see the ground is right there, and if we want to know when it hits the ground, we just, if you're in Desmos, just move your cursor to the x-intercept, and that's the answer to the problem. Like how many seconds till it hits the ground? Well, the ground means that the height is equal, oh, it says it right there. I was going to say that the height has to be 0. So when is the height 0? Well, we have to figure out the 0, and we move the cursor to the left of the x-intercept, and we move then the cursor to the right and back it up, and it would give us 3.162 as the approximate number of seconds it takes for that rock to hit the ground. So 3.162. So we would do this. This is the work that you would need to show. 3.162 comma 0, and you would say therefore about that's approximately equal to 3.162 seconds for the rock to hit the ground. And that's the answer to that problem. Glad I used started a new video for that.